Hello everybody, welcome to my channel and video. I'm Rahman Farhat and today I'm gonna explain the problem number 420 of the book Demidovich. Basically the problem is find the derivative of y and y is equal to 2x plus 5 cosine squared x. Now, if you open the book, you'll easily see that all the problems from 409 to 466 can be done with the appliance of chain rule. Now, let's explain what's the chain rule itself. Suppose that you have two separate functions, fx and gx. Yes. And suddenly you want to apply the gx to the fx. Now, you'll get a composite function, f gx. Excellent. Now, I think all of you know it from the school mathematics. Now let's delve into it and find the derivative of it, d dx. Chain rule says that in this particular example, the derivative will be the derivative of f gx with respect to the x. We find the derivative of f and then apply the gx. But it's not done. Then we'll multiply it by the gx itself, the derivative of gx itself, sorry. Yes. Now we're done. And let's apply it to our function. Our function is y equals to 2x plus 5 cosine squared x. Some rule tells us that if we have two separate functions, yes, take them as separate functions. For example, this is fx and this is gx. And if we have two separate functions and we want to find the derivative of their sum, we can find their derivatives separately and then add them. And this is sum rule. And let's apply it. Y equals to d dx 2x plus d dx 5 cosine squared x. Excellent. Now let's find them separately. First of all, this. Let's write it in a bigger manner. Yes, d dx 2x. The constant multiple rule tells us that if you have a constant multiplied by a variable or differentiable function, we say, we can take this constant and put for it as 2 d dx, 2 dx dx. So it's obvious that their derivative is 1, but let's prove it. Yes. We know from the power rule that the derivative of xn with respect to the x is n multiplied by xn minus 1. Then the derivative of x1, let's say it, will be 1 multiplied by x1 minus x0. x0 is 1, so it's 1. Excellent, we found it, that we proved it that it's 1. So that will be 2. Yes, we can write 2 instead of it. Now let's clear the board, this part, and focus on the second function. And that's the point itself. Find the derivative of d dx 5 cosine squared x. Now, as we mentioned, we can use the constant multiple rule here also, and it will be 5 cosine and the 5 multiplied by the derivative of cosine squared x. Now, let's think about cosine in this manner. ux equal to the x squared and ox equal to the cosine x. Now, and suddenly we want to apply this cosine x to the x, and it will be the composite function, and it will be cosine squared x. Excellent. Now, let's use the chain rule now for finding the derivative. will be 5 multiplied by, now if you see, it will be derivative of first function 2, but instead of x, we'll apply the cosine x to it, and it will be 2 cosine x. Then we'll find the derivative of second function. It's cosine x, the derivative of cosine x. So derivative of cosine x is minus sine x, and it will be equal to minus 5 multiplied by 2 sine x cosine x. Now, as you know from school mathematics, the multiplication of 2 sine x cosine x is equal to sine 2x. Excellent. Now we know that it will be minus 5 sine 2x. Let's put it here also. There. Yes. It will be minus 5 sine 2x. Yes. And we're almost done. Let's write our final result. Yes. It will be. Let's write it. Is that Newton notation? No. The derivative of y with respect to x will be 2 minus 5 sine 2x. Yes, we have done with our solve and explanation process. Thanks for watching my video. Goodbye.